Good morning, Lesser. I'm going to delineate Amo Chhu and then find out this volume change. To delineate Amo Chhu, firstly, I will download its digital elevation model map from the USGS Earth Explorer site. And from here, I will search Bhutan on this map. I found the Bhutan's map. And then since we know the Amo Chhu is a transboundary river that originates in China, and then it flows through the districts of Ha and Samtse, and then it leaves through Phinsuling before entering the Indian plains. So I'm going to zoom in the Ha and Samtse district. Ha would be probably here and Samtse would be probably here since Phinsuling Samtse lies next to Phinsuling. And then I'm going to download the digital elevation model maps using the polygon method. I'm going to digitize this area. Now I have digitized this area. From here, I will go to datasets and then I will search data digital elevation and then I will go to SRTM and then I will check this and then I will go to results afterward. And then now I have got the digital elevation model maps, a lot of digital elevation model maps of this area. So I will check the footprints. I'm downloading the footprints. I've downloaded one footprints. Now I will download the next footprints. Since I have done with downloading the footprints, now I will directly go to QGIS. And then I will press on new project. Go to layer, add layer, and then click on add raster layer. Close it. And then again go to layer, go to add layer, click on raster layer, choose the DM file, then click on open and then add it and then close it. Now the two DM files has been added. I have downloaded two DM files because the one DM file is not sufficient enough to cover the whole length of the Amo Chhu River. That's why I have downloaded the two DM files. Now from here onwards, I will mosaic these two DM files. To do so, go to raster and then to miscellaneous. Click on build virtual raster. Select the input layers, give input in the input layers. I'll give this two DM files and then click on OK. And then after that, uncheck this and then run. Now we have mosaicked these two layers. Now I will rename it. Firstly, before renaming, I will remove these layers because we don't need it. What we need is the mosaic layers. And then I will rename this as DM as digital elevation models. And then afterwards, I will find out its properties. And then in information, I will make sure that the units are in meters and CRS is not in geography. Since the CRS and units is in, one is in degrees unit and the CRS is in geography, I will make corrections. To do so, I have to go to raster and then to projections and then click on warp project, and then the input layer will be this digital elevation model, and then I have to choose the target CRS for this digital elevation model map will be to graph, and then from here I can just run it. After that I can close it, and then also I'll make sure that I have chosen the coordinate reference system as to graph, and then I will apply it, and then I will remove this digital elevation module because we don't need it. We need the reprojected one. So I will rename this reprojected as reprojected them, and then afterwards, since this digital elevation model maps, it contains some distortions with the presence of scenes. To remove it, I will fill the scenes by using Wang and Liu methods. To do so, search FILL fill, and then I will use fill scenes under Sarah tools, which is presentarial analysis, so Wang and Liu method. I'll open it. From here, I will use my DM will be the projected DM, and then I will save this field DM in my desktop. I will rename it as a field DM. I will give different names since I have field TM already present in my desktop. I'll give field TM. I'll save it, and then I will uncheck these flow directions and the watershed basins because I don't require it. And then now I will run. Now it's executing its tasks. It is filling the scenes present in the original digital elevation model maps. Now I will press on close. Now I will remove this reprojected DM because I don't require it as it contains distortions. Now I will use this fill DM to delineate the Amo Chhu River. To delineate it, firstly, I will find the style order of all the rivers found in this digital elevation model maps. I will use the style order present under the Saga tools. I will execute it. And in the elevations, I will provide a fill DM. And then I will save it to my files. I will name it as style order 7, and I click on run. After that, I will close it. For better visualization of the stream, I'll go to the properties, and then I'll go to symbology. In render type, I will give single band pseudo color, and in the mode, I will provide equal interval. And from here, I will search the color RAM, go to color RAM, create new color RAM, choose CPTCT, okay, and then I will choose blue, apply. To classify streams and to sort out the smallest streams, we can see lots of small streams on this digital visual model maps to sort out these. And also the Amo Chhu river, since the big river to have style order greater than 7, I'll use a raster calculator to show place it on style order. Firstly, I will define output layer as Scala order of 7. Save it. So I will clear it. And then I will use greater than equals to 7, and then click it OK. Now we have a stream of style order greater than 7. We can also change the symbology of our streams. To do so, I will go to properties, and then from symbology, I will select unique values in render type, and then click on classify. And then I will apply it, and then I will click on make this outer area transparent. I'll go to its properties and then to transparency. In this, I'll give values row, and then I will apply it. If I uncheck this style order 7, and then the field TM, we will get only the streams of style order greater than 7, and our background will be transparent. Firstly, I will zoom it to layer, zoom to layer. I'm going to calculate the length of Amo Chhu Before doing so, to locate precisely and exactly the Amo Chhu River, and to ensure that I have chosen an Amo Chhu River correctly and to leave no doubt, I will use OSM standard base map as a reference. To add OSM standard base map, go to web and then to quick map services. From here, choose OSM standard, and I will zoom in to locate exactly the Amo Chhu. I have found the Amo Chhu River, and now I will create a line shape file to calculate the length of the Amo Chhu. It's flowing through Bhutan. To do so, go to layer, and then to create layer, click on new shapefile layer. I'll give file line as a then for Amo Chhu, save it, and then I will choose geometry type as a line. I'll click on OK. Click on toggle editing. Click on add line feature. I'm going to trace the Amo Chhu River. Now I have finished tracing the length of Amo Chhu River till its outlet. I will zoom it to layer, and then go to its properties. Change its color, blue, green, increase the stroke width a bit, and then apply, and then OK. This is the traced length of the Amo Chhu River that flows through the Bhutan, starting from the Hajongkak, and then through Samti district, and then through Phinsuling as its outlet. To calculate the length of the traced Amo Chhu River, open its attribute table, and then use open field calculator. Give output field name as len, and then output field type is decimal number. And from here, go to geometry, and then press on $sign length, and then length of the Amo Chhu river will be automatically calculated. And then press on OK. And the length of the traced Amo Chhu river in meters, it is 75,549.476 meters, and in kilometers, it is 75.549476 kilometer. Now I'm going to calculate the volume of Amo Chhu by creating a drainage basin at its outlet. To do so, I will unselect the length of Amo Chhu. I will select the field TM and then installer order 7 and then installer order of 7. And then under processing toolbox, I will search for channel and I will select channel network and drainage basins. I will execute it. And in the elevations, I will provide field DM and then I will give threshold value of 7 and I will unselect this flow directions. I'll unselect flow connectivity. I'll unselect stall order similarly, and then I will unselect drainage basins. I'll unselect drainage basins. I'll unselect junctions, and then I will select only the channels and save the channel to my desktop, and I will name it as simply as channel of rivers, and then I will save it, and then I will run it. Now I will close it. And as we could see, the channel of the river has been created. To create a drainage basin at the outlet of Amo Chhu, I'll uncheck this channel reverse. I'll also uncheck the installer order 7 and also the field TM. I will check OSM standard base map and length of Amo Chhu 2 to locate easily the outlet of Amo Chhu. From here, I will zoom in. Now I have found the outlet of the Amo Chhu river. That's this pixel. And now I'll find out, extract the coordinates of this pixel. To do so, I'll zoom in. And then from here, I'll copy this coordinates to my notepad. And then I'll find upslope, use this upslope area presented in this hydrology. And in this target X coordinate, I'll provide the X value. And also in the target Y coordinate, I'll provide the Y value. And then in the elevation, I'll provide fill DM. And then in the methods, I will use deterministic 8. And then simply press run. Now the upslope area has been calculated and a catchment has been delineated. Catchment of Amo Chhu River has been delineated. I'll zoom it to layer. This is the catchment of the outlet of the Amo Chhu River. And now this catchment is in raster form. And this is the outlet of the Amo Chhu. To convert this raster form into polygon, go to raster, then to conversions, and then to polygonize. In the input layer, provide upslope area, and then save it to the file. Name it as simply as shape, that is since the shape file. Press on OK. Since it already exists, I will give it different name. I will give catchment. I'll just give basin shape. And then I'll click on run. Now close the parameters. Basin shape has been created. And then to remove all the outer colors and keep only the inner colors, firstly enable the toggle editing. And then I will open the attribute table of this basin shape. We'll check, delete it. I will check the colors. If it doesn't match, I will delete it. I should not delete it because this is the inside colors of my catchment area. Now I will delete all the outside one. Now I finished deleting all the outside one. Now I will save it and then enable the toggle editing modes and then close it. Uncheck reverse, uncheck upslope area. Firstly, I will rename this layer. Rename this layer as Amo Chhu Basin at outlet. And then afterwards, I will check the channel of rivers and then change the basin color to green. And then I will also change the color of the channel of rivers to blue. Okay, apply it, then click on OK. And then to only extract the streams, streams and this Amo Chhu river that contribute to the Amo Chhu basin at its outlet, and to clip all these streams that are present outside, which doesn't lie inside my area of interest, I will use clip tools. Present the saga. In these clip features, I will provide Amo Chhu basin at its outlet and input features as the channel of rivers, and I will save it to the file and name it as clip channel. I will give you different names since this name already exists. I'll give it clip Amo Chhu basin channel, and then I will save it. Click on run. Close it. Now I will uncheck the channel of rivers since I've created the clipped Amo Chhu basin, since I've clipped the streams, and then I'll also uncheck the OSM standard base map. I will change the colors of the clipped streams to blue. Okay, and then apply. I will increase the stroke width a bit and then click on apply and then OK. Now I've created a Amo Chhu basin at its outlets. Now I will calculate this volume of the basins, perimeters of these basins, and area of these basins. First off, to calculate the perimeter and area of this basin created outlets, direct to open attribute table, enable editing mode, and then use open field calculator. In the output field name, give it area, choose decimal number, go to geometry, press on $sign area, and area has been calculated. And then I will calculate a perimeter, give open output field as perimeter, and choose decimal number, go to geometry, and select for perimeter, press on this $sign perimeter. Perimeter has been calculated, click on OK. The area of this basin is around 515,000 and 570.38274 kilometer, and the perimeter was 210.601848 kilometer. And then to calculate the volume, we'll save it and close it. To calculate the volume of the Amo Chhu basin at its outlet, I will use field DM. From here, I will extract the field DM using clip raster with polygon methods. In the input, I'll provide field DM. In the polygon, I'll provide Amo Chhu basin and then simply run it. It is extracting the field DM. Now close. I've extracted the field DM. I'll uncheck this field DM and I'll move this on the top. Now from here, I will change the color. So go to symbology, select single band pseudo color. From here, I'll create new color ramp, use gradient. Provide light green here. At this, I will provide dark green to show that it is present at higher elevations, like to show mountains. Okay. I will use equal interval if class is 10, and then simply press on apply and press on OK. Now from here, I will calculate the volume to do so. I will use volume calculation tool, press on raster, and then press on volume. In this, I will provide Amo Chhu BaseNet outlet since it's a polygon layer, and then I will provide in DEM height layer that is the clipped DEM, and then in this choose type of base height, I will provide manually. I will provide 1 meter because the average depth of the Amo Chhu river is 1 meter. Now from here, I will reduce the sampling size to get more accurate results, like say 54.23. Similarly, 54.23. And then I'll simply press on run. Finally, this is the volume of the Amo Chhu basin at its outlets. And I've not recorded while calculating volume because it takes a lot of time in the conversions or in calculations of volume.